The continuation of previous videos. Here we are going to discuss about applied chemistry field UV spectroscopy. I am Dr. R. K. Shankarana, Assistant Professor, Department of Chemistry, SNH, SNS College of Engineering. So previously we have discussed the spectroscopy instrumentation. Here we are going to see how the splitting are happening in the natures. Okay, so generally that waves like what will be the light radiation? It's like visible and UV light. Generally it will be there, and those are interacts with the electromagnetic radiation. So what is happening that the energy that light will fall on the prism, that will split. Okay, if waves are coming into the prism, what will happen? It will split, it will give the different colors, which means particularly wavelength. Okay, so the UV light that generally 10 to 100 nanometers, and near ultraviolet is 200 to 280 nanometer, visible light is around 380 to 780 nanometer, and near infrared and 780 to 3000 nanometers, and you can say the mid infrared what that will come around 3000 to 20,000 nanometers. So far infrared 30,000 to beyond that 3 lakh nanometer. These are the light which come from the sources, which may be electromagnetic radiation or photo light effect and all the effect. These are all coming from source, which we can split into these many categories. Okay, in this category we can use only spectroscopy. We will use only UV visible regions. So how the machine is working, that UV spectrophotometer, how it's working with instrumentation concept. Here what happening, that Beer-Lambert's law, one is there, that scientists they invented Beer-Lambert's law. They found the formula and they have mentioned incident light and transmitted light. Based on the concept, they have studied the spectrophotometer. And Beer-Lambert's law, what its incident light is I0 and transmitted light is I. So these are the main concept. Here what happened, that S0 and S0, that is the energy level, they are splitting into the two ways. That ground state is called E1 and excited state called is ground state is E0 and excited state is E1. So the when light is passed on the substance, that will excited to the another energy level, that is called E1. So what is the difference? Both state there is difference, that E0 minus E1, then which means that ground state we are giving some light source. What will happen, it's fall on the substance, that will get excited, it move to the energy level, next energy level, that is E1. That delta E is equal to h nu, that is which means that pass of energy. So this is the things happening in the UV spectrophotometer. Okay, so in this case we are having the single beam and double beam. What is the use of double beam and single beam instruments? So if you are thinking about unknown samples, we need double beam. If single beam means no need enough reference samples. If it is single beam means just we can do the calculated level. Calculated means already it's a fixed one. We have to find some values in this case. Example, concentration. If the serial dilution method if you are using means, we will keep the samples one by one. We can calculate whether its concentration increase or decrease. This is the way we have to calculate it. So this is the single beam. So just we pass the single beam, and double beam means the fluctuation of light source cover the time and all the things will get nullified, which means that baseline correction might have happened in this double beam. So okay, what are the things are happening in the UV light? If you pass the UV light on the samples, what are the things are going to happen in materials or samples, whether it's organic or inorganic? There is several things are there. There is bonding and anti-bonding. non-bonding, bonding. The energy levels differ from the anti-bonding, one bond energy to another bonding, which means generally what will happen, bonding to anti-bonding or non-bonding. These are things going to happen, and bonding to anti-bonding, and these are normal things. What are the things? Anti-bonding, pi star level to sigma star. Those are energy levels, which means some elements, some chemicals are need less energy and some chemicals are needed more energy. For example, if fellow is very thin, those fellow is need very less energy, and those fellow is some other fellows little fat and strong, so he need lot of energy to upward to move upward. So this is the simple concept we can say. Okay, so generally that pi bonding and n bonding, non bonding, those are lone pairs of electrons, and these contain, and another one is sigma bond to pi bond, thus bonding is containing lone pairs. So here you can see the previous slides discussion. If you are applying the energy, what happens that C double bond C, sigma to sigma star. Okay, what is sigma to sigma star? Bonding to anti-bonding. Another one is C double bond C, where it's going bonding to anti-bonding, pi to pi star transition. Generally that what will happen, that C double bond C, pi to pi star, and C double bond O, what are the things going to happen? Same concept, bonding to non-bonding, which we bonding to anti-bonding, which we called as a pi to pi star transition. And another one is C double bond C bond C double bond, which means what are the things, bonding to non-bonding some cases, because that lone pairs is completely filled. So what will happen, that move to the non-bonding. So these are the ways we can explain about the chemical structure and energy level of the UV visible spectrophotometer. And here you can see the some energy levels. Alkenes 177 nanometer, that is N2 pi star, and these all the things are happening, all the chromophores, which means keto, nitro, azo, amide, all the things are, it's like a chromophores, which means that will emit the energy, absorb the energy, it will move to the bonding level. Thank you. Sorry, one more thing, these are the applications: pharmaceutical industry, biotechnology and life science, material science and environmental analysis, food beverage, forensic science. These are the basic instrument is which one? UV spectrophotometer. So it's very basic and essential for analysis. It's not only basic, it's essential for basic analysis of chemicals and all the departments, because if you want to find the concentration, whatever it is, some errors, error analysis, concentration, strength, whatever it is, that lone pairs of electron, which chromophores existence, all the things you could find. Thank you.